Alright then, let's start with our discussion on advanced modification tools. The drawing file that I'd asked you to download was exercise 7A, array demo. That's found on the exercises section of our Canvas page. What we'll be doing is we'll be talking about making patterns, making geometric figures like this square into layouts of patterns. Now, we can imagine that this square represents a lot of different things. Maybe it represents a table in a restaurant. Maybe it represents a desk in a gymnasium where there's some testing going on. And, if we only needed a few desks, well, the copy command is very sufficient to do that. Copy command is pretty straightforward. But when we start having to make lots of copies, then copy command kind of drags. So what we're going to do is we're going to look at a new command, and the command is called array. And there are three different kinds of arrays: rectangular arrays, polar arrays, and path arrays. And we're going to see how they make the process of copying things into patterns much easier than doing it the long way of using the copy command. So the first one we're going to look at is a rectangular array, and what that will do is it will make copies of objects for us into rows and columns. So, as an example, click on rectangular array, select that select that rectangle, hit enter, and right away some things happen, right? That was exciting. So, what just happened? Well, AutoCAD took the original square and it put it on the layer that's now current, and it made 4 columns and 3 rows, right? 1, 2, 3, 4 columns, and 1, 2, 3 rows. Now, this array is obviously created much quicker and easier than trying to copy this stuff out one piece at a time. You see the ribbon has changed. It's no longer the Home tab. It's a new tab called Array Creation. What it does is it lets you go in there and it lets you modify the parameters of the array. So if I say give me 6 columns, well, suddenly I've got 6 columns. If I say give me 2 rows, well, now I've got 2 rows. See, the parameters in the boxes match what you see on the screen. If I wanted 36 squares, well, this is definitely the easiest way to do it, right? Especially since they're all evenly spaced out. Now, you could adjust the number of columns and the number of rows by adjusting the numbers up here. You can also adjust them by using the grips. You'll see that there's a grip on the top left corner in the Y direction, a grip in the bottom right corner in the X direction. There's also a grip out here in the opposite corner of the origin. And clicking on the Y grip will reduce or increase the number of rows. Okay, so if you want to dynamically add rows, you can do that. Clicking on the grip out here will dynamically control the number of columns. So we can reduce the number of columns or increase the number of columns. And then clicking on the grip opposite the origin, well, what that does is it does rows and columns at the exact same time. Okay. Now what we've done is we've taken the original and we've copied it, and we've copied it into a pattern that would be much easier than creating a pattern one copied instance at a time. Now there are some weird little things about array that bear mentioning. First thing, I want you to see how this box, all of these boxes actually now, they are 5 inches by 5 inches. Yet when I click on any of the elements of the array and I look at the parameters, I want you to notice the spacing. It says the between distance is 7.5, and that's in both X and Y direction. Now, take a quick look and tell me what you think. If this is 5 inches from here to here, does this gap from here to here look like 7.5 to you? See, it's not, is it? So what do you suppose the 7.5 refers to? So if you guessed that it is the distance, not of the gap between, but the distance from the corner down here to the corner of the next one, well, then you are correct. Yeah, the spacing, the between, would be the distance from that corner to this corner, which is 5 plus 2.5, giving us that 7.5 total. Right, there's 2.5. So when we click on the array and we see the distance and we start adjusting it, we can understand a little bit better what it's doing as we're asking it to make some space changes here. If I say give me 6 inches between, that doesn't mean a 6-inch gap. It means from the corner at the top left to the next corner at the top left, there is 6 inches. And then what does that mean? Well, it means the inch is at the gap is only really an inch, right? Because we had a 5-inch box we started with, and we asked for a 6-inch spacing. Okay, so as long as you can keep that straight in your brain, that'll be good. The between is not the space. You know, AutoCAD's smart, but it's not that smart. It's the start of one point to the start of the next point in the same figure. As you ask it for a certain number of columns and a certain number of spacing, it will also give you the total. As you ask for the certain number of rows with spacing, same thing, you get a total. So in 4 columns, from the first one to the last one, from here to here, right, telling us that would be 18 inches. So the numbers dynamically change as you adjust the spacing and you adjust the number of instances in the array. Now there's another couple of grips here. There's a grip here, and there's a grip here. And what these grips do is they allow you to adjust the spacing, but again, it's kind of by eye, right? We're kind of eyeballing things. This would be if we don't have any technical specification or distance, and we're just kind of making something that looks pretty. I guess we could use that grip there to make it pretty. Most of the time, though, we're not going to be working with odd numbers like this. We're going to be working with some solid numbers, so we have precise control over distances. Now, I want you to think about this. How could I get the one box here to touch the box next to it? What would I have to set the between distance to? Well, if you said 5, you're correct, because if it's 5 from the first corner here to the next corner here, that doesn't leave any gap at all, does it? So I'll make that 5, and I'll make that 5, and we see how the gaps have disappeared because the between distance is actually the size of the elements in the drawing. So far, so good. Let's move over a little. Let's put it to the test. So without moving the square I gave you, make a rectangular array with 3 rows and 2 columns, and leave an inch between the rows and columns. Okay, so we'll go rectangular array of that item, and then you work with the distance to get the row and column distance that leaves behind 1 inch. And if we have AutoCAD 2021 or 2020, we know that the measure tool is kind of cool. It'll show you the gap right there on screen. All right. Now, we're not just stuck working with squares. We can make any geometric figure into a rectangular array. The idea is we're making copies in columns and rows. So without moving the given circle, let's make a rectangular array, 3 rows and 4 columns. 3 rows, 4 columns. And from the center of one circle to the center of the other, there should be 8 inches. Now, how are we going to accomplish that? Center of this one to the center of that one. See, I didn't give you any sizes. You don't know how big they are. What are we going to do? Well, the fact is you don't have to do anything, do you? Because I didn't say from the edge of one circle to the edge of the next one. I said from the center to the center. And all that is, it's the between distance. Right? And if you were to go in and do a little bit of measuring from the center points, from the center of this circle to the center of this circle, you'd see we have our 8 inches there. Okay. Now you might be wondering, how come you didn't show us this when we did the classroom? Because we had to copy a bunch of desks with computers and monitors and chairs and keyboards, and it would have been so much easier just to do an array. But actually, not really. I mean, look at the classroom, right? Are there the same number of desks in each row? No. And if we measured the classroom, was there the exact same spacing between each row? Again, the answer is no. So array wouldn't have really worked that well to set up the desks in the classroom. I don't think. It would have taken a lot more effort to use it than just copying. Okay, so that's why I didn't show it to you previously. Okay, if we take a look down here, we see I've actually made a little building, a little skyscraper. So this is the elevation or the facade of a high-rise building, and down here I have a window. And it's a block. And what I'd like to do is I'd like you to make windows all over the facade of the building. So now in the old days of drawing by hand with a pencil or a pen, this would have been a lot of work, right? But with CAD, it is quick and it is painless. So we will make a rectangular array with that window. And the row spacing will be 16. And the column spacing will be 12. Okay, and when we take a look, we see we've got a lot of rows and a lot of columns, right? So now that's too many instances, though. We don't need all of these windows. So remember, you can just grab and drag using those grips on the array until we have enough windows on the building, but not so many that they go outside the building. So I didn't give you a number of rows or a number of columns because really you don't even need it if you're trying to fill in an area. Alright, so that's a lot of windows, right? And what did you have to do? Nothing really. A couple of clicks, and now our elevation is completely full of windows. Now, the nice thing about arrays is that the parametric control, or the numerical control of the spacing and the number of instances, that will always be part of the file. So if I save this file tonight and open it up tomorrow, and I click on this array, I see that the array is associative. It is associating its display with the information in the box here. So if I decide to change the distance to 10 between columns, then I decide to change the distance to 15 between rows, see, that will update for me, not just on the day you're working on the file, but a day later, a week later, a month later, 5 years later. This array will not lose the ability to update itself every time you open the file up. And that's awesome, because what if there are changes, right? You don't want to draw all these windows and then have to erase them and start over with new spacing. Even in CAD, this is a tedious operation if we were just using the copy command. Okay, so the beauty of arrays are they are associative, which means that there is connection between the parameters up here and what you see on the screen. And changing one updates the other. And changing one up here updates what you see down there. Now, in a way, though, that's kind of tough, too, because once I have copied all these windows, this is an array. It's a new kind of object. I can't select this window here and just delete it because the array is associative. It's all linked together. Deleting one window deletes all the windows. So what can we do if we have to make an adjustment? Let's imagine the second floor down here, right? Second from the top. I'm going to get rid of all the windows in the middle because the owner of the apartment wants some privacy. Well, there's a few things you can do. One of the things is when you're working with an array, select the whole array and hold down Control. Now you can go in and select items within the array. This is called sub-object selection. See, we've selected the array, but now we're trying to get something inside of it. And now if I hit delete, I am only deleting those things that I selected. That's kind of slick. It's kind of slick because look, this is still an array. And if I go to change the spacing, you see how it didn't fill those back in, right? See, it's leaving the gap that we originally created where those windows would have gone. That's kind of cool. Okay, and that is one way to work within the array to get rid of things that need to be removed without breaking the associativity of the array. Hold down Control, sub-select, or sub-object select, and then whatever you do will be carried through without breaking the array. Okay. Now here's another scenario. We'll make another set of windows. Now I want you to see how the windows are going up and to the right. Windows are going up and to the right. Let's use that same spacing. They said 16 and 12. So 16 on the rows and 12 on the columns. Okay. Now windows out in space here really don't do any good, right? Why are they going out in space? How come they're not going and filling in this area? Well, part of the reason is because of relative coordinates. You remember relative coordinates? It was so long ago, right? Relative coordinates say the values, if they are positive, go to the right in the x direction and up in the y direction. So if we want to go to the left, notice that now we have a negative value. Now if we want to go down on the y, again, notice now we have a negative distance value. Okay, so here's the original one. Moving to the left, I need a negative x for the columns. Moving down, I need a negative y for the rows. Okay, and our little 4-story building is all set up now. So this is our first kind of array. It is called a rectangular array. It is ideal when you've got to take an object and create a pattern that involves columns and rows. And this really cuts down on the tedium that would normally be associated with the copy command doing something like this.